Hi, everybody. I'm going to do problem 1 from worksheet 5. And we're going to just start off with, given that Z1 is equal to negative 2 plus 3i, that's in rectangular form, and Z2, they're giving us 6 at negative 50 degrees in polar, compute the following. First, I want to compute Z1 into polar. First thing I do is I want to say that Z1 is equal to the square root, and this is the magnitude of Z1. That's what I'm looking for. And remember, it's the square root of the value, the real part, plus the imaginary part. So this is going to be equal to the square root of 4 plus 9, which is equal to the square root of 13. And that's it. That's all you really have to do. I've gone through these problems in lots of other videos. So in other videos, I've explained why I do every step. If I want to know what theta is, it's the inverse tangent of y. Remember, that's yi over x. And I've always said, take the absolute value and get the reference angle. So this would be the inverse tangent of 3/2. This is a calculator problem. If we give you a problem that you cannot solve without a calculator on the test, that's the final answer. You would need to put this in the correct quadrant. For example, since it's going -2 in the x direction and +3 in the y direction, it's going to be in quadrant 2. So whatever this is, I would subtract this reference angle from 180, and that would be the correct angle. This is equal to 56.31 degrees. This is the reference angle. And if I were to plot that, I need an x and a yi. X is -2, yi is +3. There's my point, and as you can see, that's in quadrant 2. What I need to do is I need to say, okay, well, if I start here at 0 and I go to here, what is my angle? Let's put this in as our terminal point. What I'm doing for the reference angle is I'm going all the way to 180, and then I'm going to back up to that point. That's why it's negative. So I have 180 degrees minus, this is my reference angle. Right here is my reference angle. It is 56.31 degrees, which means my answer here is 123.69. In polar, Z1 is equal to the square root of 13 at an angle of 123.69. Now, if you watch the video on multiplying and dividing rectangular and polar coordinates, what it says is that if I want to know what Z1 times Z2 equals, I multiply the magnitudes and I add the angles. So let's just do it. Here, this would be at an angle of 123.69 minus 50 degrees. So this would equal the square root of 13 times 6 at an angle of 73.69 degrees. Now, I want to put this in rectangular. So I would say 6 times the square root of 13 times the cosine of 73.69 plus I sine of 73.69, which is equal to 6 times the square root of 13, and the cosine of 73.69 is 0.28 plus 0.96i. And then if I want to finish it off by distributing the 6 times the square root of 13, I would get 6.06 plus 20.77i. If you remember, I multiply the magnitudes and I add the angles. I have this as a polar, and I have this is in rectangular. To find the quotient of two complex numbers, we can say what we're going to do instead of multiplying, we're going to divide the magnitude of each of the complex numbers. So we would have the square root of 13 divided by 6. What we have to do is say the angle is equal to Z1 minus Z2, which is equal to, well, Z1 is 123.69 and Z2 is negative 50. So negative 50 is equal to 123.69 plus 50, which is equal to 173.69. Now in polar, we have the square root of 13 over 6 at an angle of 173.69. In rectangular, we would say the magnitude of the division times the cosine of 173.69 plus I sine of 173.69. I'm going to put this into my calculator. I'm going to get that the cosine of 173.69 is equal to negative 0.99. Then I have plus I times 0.11. And that equals negative 0.57 plus 0.67i. And that is my final answer for rectangular. what did we do? We divided the magnitudes and subtracted the angles. And that's the end of problem 1.